Today we're looking at a second example for doing a hypothesis test for two independent group data. So if you read the description of the problem, you'll notice that we want to be able to see if there is a difference in the mean number of party days for male versus female PSU students. And so to be able to test this, we're going to test it using an alpha of 0.05. Now, one thing that's helpful is identifying each of the two groups. So, highlighting the females in green, we have a sample size of 382, we have a mean of 754, and we have a standard deviation of 5.46. So then for male PSU students, highlighting it in blue, we have 308 as our sample size, a mean of 7.45, and a corresponding standard deviation of 5.45. So this is going to help me in terms of how to define the two groups and also doing my calculation. So starting out in step one, remember we're going to identify our populations. Now we have two populations, so population 1 I'm going to choose to be female simply because their sample mean is larger and I would rather not calculate a negative test statistic, but because we're looking for a difference, it really doesn't matter which group is group 1 and which is group 2, just as long as you remain consistent for the whole hypothesis test. So population 1 is going to be all female PSU students, and then population 2 will be all male PSU students. So then the corresponding sample 1 will be for females, so we had 382 female PSU students, and then sample 2 male PSU students. One thing that I like to add when I am in step 1 is defining my two parameters. So here I would have mu1 and mu2. So mu1 minus mu2 is my parameter of interest. And because I have population 1 as being females, this is going to be mean number of party days per month for female PSU students. And then to clarify that that is group 1, in parentheses behind it, I'm going to put mu1 minus, and then my second mean is the same thing, so it's mean number of party days per month, but this time my population is male PSU students. And again, to clarify that that is my second group, in parentheses behind that, I'm going to put mu2. So that's step 1. Now in step 2, I'm going to define my null and my alternative. Now because I use the notation mu1 and mu2 in step 1, I'm going to use that same notation here. Now for this problem, what we wanted to be able to show was that there was simply a difference. So that means that my alternative hypothesis is mu1 does not equal mu2. Again, because there's no direction implied, that means that we don't really care about the direction of subtraction in the step 1. We just want to make sure that we're consistent throughout the whole time. So because it said difference, that's what my step 2 will be. H sub A is mu1 does not equal mu2. Now moving on to step 3, our testing step. So in step 3, remember that letter A is kind of a gimme for us because of the formulas that we use. We have to assume that the sampling distribution of x bar 1 minus x bar 2 has a normal distribution. To verify that assumption, we have to do what's called checking conditions. Here, because both samples are large and the populations are independent, So I wouldn't expect one group's party days to affect the other. We would say that our conditions are met. So next we can calculate our test statistic. Now remember, we're calculating a t-test statistic. So to do that, remember we have t equals, and then we do x bar 1 minus x bar 2 divided by standard error, which is s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. So we have t equals 7.54, that was the mean for females, minus 7.45, that was the mean for males. And then we are going to divide that by standard error. And so that was 5.46, and we'll square that, divided by 382. So all of those measurements are measurements for females. And then we have 5.45 squared divided by 308. So that results in a test statistic equal to 0.22. Now moving into step 4, we're going to make a decision. So under the null, the sampling distribution of the test statistic is a t, so it's on the t distribution. And we're going to use conservative degrees of freedom. So remember that conservative degrees of freedom takes the smaller n minus 1. So for this problem, our smaller of the two n's was 308, so we have 307 degrees of freedom. Now for this problem, we're going to use a t equal to the 0.22 that we found in step 3. We also need to remind ourselves of our null and alternative. So specifically here, we need to know our alternative, which is mu1 does not equal mu2. And remember that we call this a two-tailed test. So if we were to draw the curve centered at 0, 0.22 is our test statistic. But because this is a two-tailed test, we are also going to do the negative version. And also because it's a two-tailed test, we're interested in the area and the tails. So remember, not equal means you're not sure if it's going to be less than or greater than. We just want to see if there's in fact a difference. So that's the area that we're interested in. Now we're going to use the calculator's TCDF function to find that p-value. Because we have a two-tailed test, we're going to do both the negative and positive areas. So the area above 0.22 and the area below negative 0.22. So to do that, you would use TCDF, and then your lower bound, if I were finding the upper tail, would be 0.22 up to positive infinity, so 999. And then remember we had 307 degrees of freedom. So this is the result for the top tail. Then if I were to find the bottom tail, I could do negative 999 as the lower bound, and then negative 0.22, and then 307 degrees of freedom. So I would just add those two areas together to find my total highlighted area or my p-value. Or similarly, I could actually just find one tail if I wanted and multiply it by 2. Either way, those would result in my p-value 0.82. So with such a large p-value, I'm going to make the decision fail to reject the null because the p-value is larger than the chosen level of alpha, 0.05. And so now we'll move into step 5. So because I failed to reject, I'm going to say there is insufficient evidence, and then I'll state my parameter definition, but instead of minus, I'll replace what my symbol was in the alternative, so not equal to. So we'll say there's insufficient evidence to suggest the mean number of party days per month for female PSU students differs, or you could just as easily say not equal to, from the mean number of party days per month for male PSU students. So because that was my alternative, essentially that's what I'm saying I have insufficient evidence for, and I'm saying insufficient because I made the decision in step 4 failed to reject.